packet out, and you turn to the page that says Logarithms. Logarithms. Okay, so you should have a calculator, a writing utensil, and your review packet out now. Yes. Up until this page, yeah. So it's all on video.
We are on the page.
My shirt.
Watching videos. We're on. It's on YouTube.
Okay.
I know. I just saw it on Snapchat.
It was pretty great. It was. I'm sorry that you guys missed it. Okay. Yeah. So, the first part is evaluating logarithms, and this is the part that on your test on logarithms was with no calculator, but you're gonna have a calculator the whole test, so you will have a calculator for this part, which does make it easier. But you should be able to just evaluate them without a calculator. Okay, so I'm going to show you both ways. Okay, so log base 4 of 16, what is that? It's 2. Why is it 2? 4 squared is 16. What about log base 3 of 27?
That's 3.
3, good. Why? Because 3 to the third is 27. Now, what about this one? You know it's going to be negative. Negative 3, very good. Why? Because 7 to the negative 3 is 1 over 7 to the third, which is 1 over 343. And what about this one? Negative 3. 2 to the negative 3 is 1 over 2 to the third, which is 1 over 8. Okay, now, let's say you completely forget that and you're taking a test and you don't remember how to do it. So, how do you do it? Well, you use the change of base rule. So this one would be log of 16 over log of 4. You'd plug it in your calculator, you get 16. I mean, you get 2, rather. Okay? This one you just do log of 27 over the log of 3. Remember the change of base rule, that'd be 3. And so on and so forth for the rest of them.
So that's how you get.
Yeah.
Wait, this is some pinky chop, right?
Not exactly.
No,
This is just evaluating logarithms.
That's when you have like equals.
How do you do it with the fractions? Like, how do you like type it in? Like log.
Oh, so these ones would be log of 1 over 343 over the log of 7. This one would be log of 1/8 over log of 2. And to do log of 1/8, it's just log of 1 divided by 8. If you hit divided by, it creates that fraction symbol. That makes sense? You just have to be careful with your parentheses. Make sure you're closing your parentheses every time.
So why, if we can do the log 16 over log 4, why did you do the?
Well, because originally I taught you how to do it without a calculator.
Oh, so it doesn't matter if you do it.
No, because you're going to have a calculator on the test.
Okay, I know.
I wouldn't do that to you.
No, I mean,
I hear you. Oh, I see. Okay, sorry, Alicia. All right. Let's continue. Now. All right. These ones, it says condense each expression to a single logarithm. All right, so we have to remember the properties of logarithms for this. So the first is the product property, which is the log of A plus the log of B equals what? The log of A times
log
B.
of B. I knew it.
The log of A minus the log of B equals the log of A over B, and B times the log of A is the log of A to the B power. Those are the properties of logarithms. You guys remember these? Okay, very good. Makes me happy. Now, let's take a look. Number 15. What happens to these 4s in front? What do they become?
3 to the 4th.
Very good. And 8 to the 4th. So this becomes the log of 3 to the 4th minus the log of 8 to the 4th. But when I'm subtracting logarithms, what do I do? Yes. Divide. Becomes log of 3 to the 4th over 8 to the 4th equals log of 3 to the 4th divided by 8 to the 4th. You can just do that in your calculator and you get negative 1.7. So you plug that all in your calculator. Okay? Now the reality is these ones you could have just plugged in your calculator from the get-go, right?
Yeah. Really?
But I'm going to give you ones that are with variables so you won't be able to plug in your calculator.
Oh, sorry. How do you get to the certain power
The
other
carrot,
than 2?
just symbol here.
Like carrot?
Are you gonna have that?
Wow, really?
The seminary. Are you gonna have it after school class?
Yes, today and tomorrow. I'm not necessarily doing a helps class, but anyone who comes and needs help, I'll be in. If there's enough students that come, I will be in this room right next to us, Mrs. Mullen's room. Okay. Next. Yes, sir.
Is there gonna be like a video you made like for the final, or is it just like all the videos?
All these. There are 3 review sessions that are
Oh,
about
really?
40 minutes each.
Oh, really?
Yeah.
On YouTube?
Yeah, on YouTube.
Okay.
hmm Yes, ma'am.
Do you know why I didn't get that answer? Plugged in with the carrot and then
Because you should be doing some log.
you can do it all in one.
You have to do it all in one.
Put log in words.
Okay, now, shh. Everybody do number 19. Do number 19 on your own, please. Do number 19. Hello. I wasn't expecting you to. Oh, got it. Cool.
Go here for
We're doing one.
Rachel. Wait, just a minute. What's the U?
gold. People gold.
That's a part of it. No.
The U is just a variable. The U is just a variable. Okay, let's look. How do I do this one? What happens to these 6s? What do they become? Exponents. So this becomes log base 3 of u to the 6th plus log base 3 of v to the 6th. Okay, and now when I add logarithms, what do? Multiply. Very good. So it becomes log base 3 of u to the 6th times v to the 6th. And I'm done. And that's much more like they will be on the test. So you wouldn't be able to plug this in your calculator and get the answer. Okay? Because they're just variables. You don't know what the values of the variables are.
I have a question. 10 is opposite of adjacent.
Okay. Focus on this. Logarithms. Okay. Now look, this is an interesting one. If I'm adding a whole bunch together, the same rule applies. They just all get multiplied. Okay? So that would be log of 2 times 11 times 17, or times 7 rather. You plug it in your calculator, you just get 2.19. Okay? What about this last one here, number 20? Go take 30 seconds on that one. See if you can solve for it. See if you can do it. You got to take care of that 4 first. What does that 4 become? Very good. And then you can divide. So see if you can figure that one out.
Oh, it's Ln.
Yep.
Oh, what is that one?
E. Changes to E.
And well, ln is just log base e, but you don't have to do anything with it. You can just keep it as ln.
Oh, wait, it just
Yeah, you just keep it as ln. You don't need to change it or anything like that.
ln
Mr. I don't understand how you got the sixes though.
Where?
And you did number 19.
The 6 comes from the front. It's less than
Thank you.
becomes
Oh.
an exponent. That's this property here. B log A equals log A to the B power.
Do you change it from thumpy to thump?
No. We're not there yet. All right. Shh. The 4 becomes an exponent. I get ln of x minus ln of y to the 4th. When I'm subtracting, I divide, so it just becomes ln of x over y to the 4th. I'm done. Yes, ma'am.
Can we put ln on the numerator and denominator as well?
No, it doesn't work that way. That's a very good question. Jenny said, would that be the same as like ln of x over ln of y to the 4th? And the answer is no. You make sure you understand that. This is not equivalent to ln of, this is not the same thing as ln of x over ln of y to the 4th. That is not correct. That would not be the right answer. Okay? It's the things inside they're divided, not everything together. So good question. Yes, ma'am.
Can you explain
Yeah, sure. So let's take another look at number 19. So the 6 becomes an exponent. The 6 becomes an exponent. You see that? Okay, so that becomes log base 3 of u to the 6 plus log base 3 of v to the 6, right? But when I'm adding two logarithms, what do I do to the insides? Yes. So that becomes log base 3 of u to the 6 times v to the 6. And I'm done. It's just log base 3. That's just telling you what the base is of the logarithm. That doesn't change it. They would have to be the same in order to do this. Yes, ma'am?
For the 6, are you always going to put the exponent on the number or variable that's after the log 3? Like the log?
Yeah, so this is what you're taking the logarithm of. So the variable, would
So no matter what it is.
that exponent would always be raising whatever that is. Yes. All right. Shh. Let's continue. Now, let's go ahead and do these explicitly. It says use a calculator to approximate each to the nearest thousand. All right. This is just change of base rule. This becomes log of 3.3 over log of 3, which would be 1.09. This would be log of 30 over log of 2.
Is that the same thing that we did before?
Yep. Except now we're just handling it explicitly, which is 4.9. Everybody go ahead and do number 3 and number 4. On your own, please. Do you have your packet? I got you.
So nearest thousand? What's from here? The nearest thousand?
Yeah. I mean, but it doesn't matter. They're saying the nearest thousand. I don't necessarily care about that. I didn't round to the nearest thousand. Log of 5. Number 3 is log of 5 over log of 4.
Wait, what?
1.16. Yep.
That's the answer?
And number 4 is log of 2.1 over log of 2.
Can you not round on here?
would be rounding a little too much. But these are all going to be multiple choice anyway, so you'd be able to know. All right, flip the page. Yes. You might want to. Okay. All right. Okay. Shh. Now, here's where we get into the good stuff. All right. So, this is an exponential form. How do I know it's an exponential form? Because there's an exponent. Okay, exponent. It's telling me to rewrite it in logarithmic form. So how do I do that? Well, first I have to remember logarithmic form is log base a of b equals c, right? Okay, so it's log, what's the base of the log? 64. The only question is what's b and c? Because the base is the same for both. The base is 64. But in this case, instead of 64 and 1/2, it's like they swap. Log base 64 of 8 is 1/2. And the key to remember here is the logarithm always equals the exponent. So whatever the exponent is, that's what it's equal to. So the base is the same, and the logarithm equals the exponent. Is that clear? So to do the next one, it would be log base 12 of 144 equals the exponent 2. Okay. Any questions? With that, go ahead and do number 7 and number 8 on your own, please. So that's it. Yeah, I'm just asking you to rewrite it in logarithmic form. So you got to make sure to do that. Okay, this one would be log base 9 of 1 over 81 equals -2. And this would be log base 1/12 of 1 over 144 equals 2. You're done. See? Good? Okay. All right, so that's rewriting in logarithmic form. Now, if you look down the page a little bit, we see the inverse of that, which is rewriting each equation in exponential form. Now it's in logarithmic form, and I want an exponential form, which is a to the b equals c. Okay? So in this case, the base is still the same. It's u. Thumb, pinky, thumb. U to the v equals 15 over 16. That's where this comes in. And then for number 10, v to the 4 equals u. Okay? So thumb, pinky, thumb, or around the world, whichever one, it's like that is specifically for rewriting logarithmic expressions into exponential form.
Can you do the thumb pinky thumb thing again?
Yeah. Mm-hmm. So it would be v to the 4 equals u. Okay? All right. And remember, the logarithm always equals the exponent. So the base is the same, and the exponent is right here. Okay, so go ahead and do number 11 and number 12. This way. Number 11 and 12 you're doing on your own. All right. 7/4 to the y equals x. 2 to the u equals v. You guys following this?
Yes, sir.
Good. You guys
Done.
doing
Done.
Steven, all right? Okay. Now, these next two sections are like the meat and potatoes of it all right? So you've got it, right? You've got to get this now. Okay. Let's take a look. Solve each equation, it says. We're solving for x. Now, there are multiple different ways, and people get confused, okay? Look, this is different than this, which is different than, like, this one, okay? You have to know how to handle each one, all right? So let's take a look. When I have a logarithm equal to another logarithm, if they're the same base, which they are, then what do? In a sense, it's like I just cancel them out. I just get 5x equals 2x plus 9. Subtract 2x from both sides. And I get 3x equals 9. Divide both sides by 3. God bless you. And I get x equals 3. Any questions on that one?
That was a great one.
I really hope that there isn't a tornado drill today. Oh,
Go ahead.
Don't speak that over us.
Well, she said she hoped there isn't one.
is there?
Which number
No,
2?
because look outside. Every time it happens, like.
I feel like they didn't make it. I don't think there's tornado reports. Let's see if they
No,
make
every
it
time
up.
it's like
Just
just
keep it
outside,
secret.
everybody's like,
We
oh,
have a
tornado.
lighting thing. It was donated, remember?
Number 2. Everyone on your own. Go, 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 go.
Somebody shut it off.
Ready?
I think I heard on the
Okay, guys, you guys,
Did you get 0?
yeah, but I think we did. Yeah, me too.
Is the answer 0?
Yes.
Oh!
Shh. Let's take a look.
What math is
2 logarithms equal to each other, same base. I just set the insides equal. I add 4x to both sides.
Oh, I'm so.
No, you're not. I get 10 equals 10 plus x.
Yeah.
Subtract 10 from both sides. You get x equals 0. All right. Next. Logarithm of x, log x plus log 8 equals 2. What do I do when I'm adding? First, the problem I've got here is I've got 2 logarithms on the same side, and it looks weird. But what if I combine them to 1 logarithm? Will it be easier? Yes. How do I combine these? What could I do to simplify that? Yes. Becomes log of 8x equals 2. Now, this is where your skills of rewriting logarithmic expressions come into play. Okay, I can't do anything with this because I've got 8x inside the logarithm. So I have to rewrite it as an exponential. What's the base of this log? 10. So how would I rewrite this as exponential? 10.
Seconds equals 8x.
Very good. So 10 squared, 10 to the second equals 8x, or 100 equals 8x. And then divide by 8. I get x equals 12.5. And I'm done. Go ahead and do number 16 on your own.
So do you just combine the logs?
Yeah, because it's log plus a log. It becomes log of 8 times x. But 16 is different.
Oh, this is negative.
So you divide them.
Yes.
So the rules flip flop though.
When you're subtracting, when you add, you multiply. When you subtract, you divide. Number 16.
This one here wants to do this. My Bible. And what? It's my five possession. And whenever when it does things come in, I have them sign it. Like they're overs. I got like a whole bunch like maybe like Brian gets those. He's gonna get sick for it. So I have a whole bunch of them.
That's from all the
No, this is from like whenever you're being tested, you can try to I have them sign it.
That's really cool, man. It's really great.
Yeah, yeah.
Praise God for that. All right, number 16. What do I do when I'm subtracting two logarithms? Divide. Good. Log of x over 2 equals 1. What's the base? 10. So this becomes 10 to the 1 equals x over 2. 10 to the 1 is just 10 equals x over 2. I multiply both sides by 2. And I get x equals 20.
Steven.
Yeah.
I'm fired, bro. What is it, bro? I know you know what it is.
Okay,
What is the rule?
guys, for this one, number 23, because I just want to make it a little bit easier. Are you guys good on these? I'm going to delete them.
What is the rule?
Now look, shh. I want you guys to change number 23. I want you to change number 23. Cross out plus 2, so cross that out, so it's just ln of 3x, and then make this plus. Okay? So cross that out, just make it. Does everyone follow that?
I follow.
So it's ln of 2 plus ln of 3x equals 1.
Yeah.
Okay.
So beautiful. Oh my gosh.
So I combine them, right? So it becomes ln of 2 times 3x, which is 6x, equals 1. What's the base of ln?
Wait. No, E. Oh, you're right.
The base is e. The base of ln is e. Don't be confused. This becomes e to the 1 equals e to the 1 equals 6x, right? It's an e.
What does the E stand for?
It's just a number.
It's just a number.
So,
It's a number.
It's a number 2.718 because it's ln.
what is that?
Okay.
Ay, caramba.
All right. Because I'm sure Brianna's not the only one with this question. Okay. ln. Look, ln is just a shorthand for log base e. Log base e. E is 2.718. It's just a number. Okay.
Yes, sir.
So that's it. So when I work with e, I just say, okay, e to the 1 is 6x. E to the 1 is just e. So e equals 6x. I divide by 6. And I can leave it just like that. X equals e over 6. I don't have to change that. Okay?
when will you what does E help you solve in real life?
What was that?
I'm truly asking. When will E help you solve in real life?
Do you know? Okay, that's a very good question. So when you put money into a bank account, right, it's interest, right?
Yes.
Well, interest when it's continuously compounded, which means not just every year you get 2.6% at the end, but by the end of the year you get 2.6%, but it's continuously compounded. So that means you're continuously getting interest every single day. Does that make sense? Which ends up as 2.6 at the end of the year. You understand what I'm saying? Well, in order to calculate how to compound a certain amount of interest every single minute, basically, and not even every single instant, it uses E for continuously compounded interest. So people in finances use this stuff all the time. It's in all their software that they're using. Okay, now let's look at the next one. Alicia and Kate.
I'm so sorry. I'm so sorry. No, but I'm doing so little.
Praise God. Hallelujah.
Shoot one time.
It's because here all weekend we did this math packet thing.
I know. She sent them in my house and we were just going at it with the math.
That makes me very happy. Well, good job, girls. All right, number 24. Shh. Shh. Okay, now what do we do when we're subtracting logarithms? Divide them. It becomes ln of negative 3x minus 1 over 7 equals 2. This isn't the easiest one to follow. Make sure you're paying attention. Ln of negative 3x minus 1 over 7 equals 2. Okay. The base of ln is what?
E.
E. So this becomes e to the second power equals negative 3x minus 1 over 7. Okay. Remember, I have to solve for x, so now I have to do the algebra stuff. Okay, what's the first step? Multiply by 7. I get 7e squared equals negative 3x minus 1. Now what? Add 1. And I get 7e squared plus 1 equals negative 3x. Now what?
Divided by negative 3.
Very good. And you get x equals 7e squared plus 1 over negative 3. And there you go. Done. Okay. Yes, sir. Yes, you might want to wait 10 minutes, though.
Long
You
time.
can do it.
Yeah.
You can wait, how about 2 minutes?
Alright.
All right. Shh. Turn to the next page. This is our last page. Here we go.
The last page of the whole packet?
No. There's more pages in the packet. Just this is the last page we are going to be going over. Yep. Because the other stuff is just on permutations, combinations, and probabilities. All right. You just solved exponential equations. Now we're going to, you just solved logarithmic equations. Now we're going to solve exponential equations. Now, in this case, in this case, good. What are we going to do? We have an exponent. We can't solve for it in this form. What do? We have to rewrite it in what form? Log form. So it's log base what?
6
Of
9
equals n. Therefore, n equals the log of 99 over the log of 6. You see that?
Alright, I don't remember ever doing that. So. If I plug in a log 699, will it give me the same answer as 2.5?
You can't do that in most calculators.
You cannot?
Wait, what's the formula for that?
Okay. To get this from exponential to logarithmic form is what we just did a couple pages ago. You guys remember that? So log base 6 of 99 equals n. That's good. But now I have to evaluate log base 6 of 99. How do I do that? The change in base formula, which tells me that log base 6 of 99 is log of 99 over log of 6.
You have to change it back into logarithmic form.
No. It's already in logarithmic form.
No,
I
but
just have to evaluate
I know,
this.
but like when you see problems like that says solve each exponential,
You have to put it-
put it in a
Whenever you have an exponential equation like this, generally speaking, you're going to have to put it into logarithmic form.
Okay.
Yes. Good.
Easy.
All right. Go ahead and do number 8. Then you can go.
I think.
Number 8. Go. Faster. Do it.
Yeah.
Do it.
Please use smart pens.
I didn't solve it.
You can do it.
Are we gonna be tested on the probability thing?
Yes. I'm not reviewing that because we just took the test on that. The way that the time worked out is we had 3 days.
Is this almost
Yeah, it's in the packet though.
Because this is the last thing we did before probability.
Wait, how many
Before-
questions are going to be on the
Yeah,
test?
exactly. What was that? 40 questions on the test. There are 5 multiple choice, 1 bonus.
5 multiple
I'm
choice.
sorry, 5 free response, 1 bonus. Okay. Got to write this in logarithmic form. It's log base 20 of 56 equals r, or r equals log of 56 over log of 20, which equals, plug it into my calculator, 1.34. Done. Okay. Next one. Number 9. The problem here is I've got this exponential, but it's not alone because there's this 5 here, you see? I have to get it alone first, so what should I do?
divide?
Very good. I divide both sides by 5. I get 18 to the 6x equals 5.2. Now I can write it in logarithmic form, which is log base 18 of 5.2 equals 6x. I would suggest evaluating this part first, which would be log of 5.2 over log of 18 equals 6x, which is then 0.57 equals 6x, and then divide by 6. And you get x equals that divided by 6, which is 0.095. Any questions on that one? Okay, do number 15. Do number 15. It's almost exactly the same. Yes, ma'am. Yes.
What, I'm sorry.
No.
What
Good.
did it say? 557 divided by 6.
0.57. I got that by doing log of 5.2 divided by log of 18.
So you solve them. Oh no, that's, oh, sorry.
Got it? You're good? You're good? You're good? Good job?
So what was the x equals?
Could you just write ln for log e?
No, you're doing number 15 right now. You're doing number 10 now, aren't you?
Oh,
It's okay.
it's in that.
You probably, yes. It would be ln though, that's correct.
Something I know how to do it.
Alright, so you have to solve that. Solve that and divide by 6. Wait, divide by 8.
So you do 15.
I'm doing, yeah.
Okay. Shh, what's the first step here? divide by 5. We get 6. So the 3m equals 4. Once I've got the exponential alone, which I now do, I can rewrite it as log base 6 of 4 equals 3m. But in order to evaluate that logarithm, I have to use the change of base form, which is log of 4 over log of 6 equals 3m. So I do that division, I get 0.77 equals 3m, and then divide by 3. I end up with m equals 0.258. Any questions on that?
Take advantage of this class. You've only mentioned that like a lot.
All right. All right. Let's take a look at number 10. What's the first step? What's the first step for number 10? Who could tell me? Add 5. Good. Add 5. I've got to get that exponential by itself. This becomes e to the x minus 1 equals 10. Very good. Now, I have to write this in logarithm form, right? So it's log base e of 10 equals x minus 1. But what's the shorthand for log base e? ln. So ln of 10 equals x minus 1. ln of 10, you can evaluate directly in your calculator, is 2.3 equals x minus 1. Then all I have to do, very good, add 1 to both sides. And I end up with x equals 3.3. So that was a good one. Everybody go ahead and do number 16 now. Do 16 on your own. Any questions on number 15? Or that one? Okay, number 16. You can do it now. Yes, sir. What was that? Yeah. You just plug it in your calculator. It's literally the ln of 2.3. Close parentheses. You're good.
What number are we doing?
Number 16, yes, that is correct. All right. First step, add 5. And then we get 58. What do I do now? Who knows? Who knows? Anybody? Yes. Log base 8 of 58 equals negative 5a. Very good. This becomes the log of 58 over the log of 8 equals negative 5a. I evaluate that in my calculator. Log of 58 divided by log of 8, I get 1.95 equals negative 5a. Divide both sides by negative 5. And I get a equals, very good. Yes.
How do you know when and how much goes out?
It's multiple choice.
Oh, okay.
good, Jen?
No, keep thinking about it.
What are you doing? Oh, because you're not doing much. You're just doing the minus 5.
Oh my gosh. I say that all year.
All right. Now, last two. Okay. Now focus in, because if you guys can do these, then you can definitely do all the rest. All right.
Let me lead the class, Miss Me.
This is what it's all for right here.
Game day, y'all boys, game day.
All right. Number 17. What's the first step?
You have to add 9.
Add 9. Very
And you
good.
get 5.
You get
You bring it down.
3.
But we gotta do a little thumb pinky thumb action. That's what we
Okay. Now what?
do. Y'all switch it up. Put the 5 with the 2 minus 2m in this.
Now, what? You good?
Make
What do I do?
it make it E 3.4. No, make it E 5. 3.4.
Say it louder, Joseph.
Huh?
Good job. You got to get the exponential by itself first. Okay. Shh. E to the 2 minus 2n equals 5 divided by 3.4, which is 1.47. Now that I've got the exponential by itself, what can I do?
Now make it log E.
Log base E of 1.47 equals 2 minus, what are you guys doing? Okay, ln of 1.47 equals 2 minus 2n. Okay, ln of 1.47, I just plugged on my calculator. I get 0.39 equals 2 minus 2n. Then it's just the simple algebra. Subtract 2, I get negative 1.61 equals negative 2n. I divide by negative 2, and I get n equals approximately 0.81.
Money.
Questions on that? All right, number 18, go ahead.
You
You
gotta
can do
add.
this one, then you guys are golden. It's fine. Round it. Yeah.
When we're doing this, do you want us to round to the 10th or the
10th or the 100th or the 1000th, just use your judgment. Okay, first step, add 3. Negative 6e to the 8n plus 8 equals 20. Divide by negative 6. I end up with e to the 8n plus 8 equals 20 divided by negative 6 is negative 3.3 repeating. So that's fine. Now change it to ln of negative 3.33 repeating equals 8n plus 8.
Wait, you kept it negative though, even those two. Wait. No.
Oh, should have been negative, sorry. So negative, positive, thank you.
Wait.
This was negative, so negative divided by negative makes it a positive.
Yeah.
So ln of 3.3333 is 1.19 or 1.2 equals 8n plus 8. Subtract 8 from both sides. I get negative 6.8 equals 8n. What was that?
They divide a little 8. Got the answer. That rest.
Doing 20 divided by 6.
Divide.
N equals 0.85. All right, let's look one more time. Look. I added 3 to both sides.
Wait, what?
Yeah, negative 0.85.
How do you get
I
that?
added 3 to both sides. Just follow. I get negative 20. Divide both sides by negative 6. I get 3.33. Take the ln. Ln of 3.33 equals 8 n plus 8. Hold on. You followed that. Listen to me. There's one last thing that I have to cover with you really quick. If I tell you I've got 3 red marbles, listen, 3 red, 4 blue, and 5 green marbles in a bag, and I tell you what's the probability of picking a green marble, what would you tell me? 5 out of 12, right?
Yes.
That makes sense?
Yes.
I didn't explicitly cover this in class, and I just have to make sure that you guys know that. Do you understand?
Yes.
All right.
Thank you for your.
Good job. God bless you guys.
Thank you for your wisdom.
Thank you. Praise God. Thank you for your blessed souls. Go on into the wild blue yonder.
Yes.
She's taken.
Bro, that's a formality,
She's
bro.
married.
That's a formality.
She's married.
I didn't see a ring. I did not see a ring. I did not see a
Hi,
ring.
Amanda. Fine. You're welcome. Have a nice day.
I don't want to like go up and be weird, like, 'cause I know that was short hair. I know that was short hair.
I'll see you in
I
my
didn't know it was short hair.
See ya.
Bye, Mr. Manure. Thank you very much.
Okay, see. Nice.
Oh, you can keep that.
Oh, should I just take a little piece?
No, no,
Knows how to do it.
I already worked around your schedule. No, I
So you don't show up.
No, but you can come.
Everybody's like in class. That's
That's what you gotta do.
what you gotta do, you know?
You put your friends above yourself.
Yo, tell me that coffee doesn't have anything. Just coffee. That's all.
No, I'll take that bit.
Give him the whole thing, man. Yeah, keep it. Keep it.
You have a nice day. I'll see you. Bye. Oh, my seniors. It's not true. I sometimes I'll fix yours too, Devin. Oh, I didn't put your grade in the book. What is your grade? What is your grade? What did I give you on that? What'd you get? I guess for whatever reason Because you took it late, and but I graded it, and I just didn't put it in. Okay. So you guys should all have your packets out, writing utensil, and a calculator.
What happened to the party?
We're having it.
You never sent us an email.
I said I was going to send an email, but then I was like, no one's going to reply. I shaved, and my wife did cut my hair, actually. Overtime. Overtime, thank you.
I'm not serious, like I'm actually not joking.
Oh, that's a crack up.
Have you ever just let it grow, like, you know, you should.
The most I've ever let it grow, I think, was like a month. I never really ever let it grow. Maybe I'll let it grow over the summer. Just let it. Okay. I believe it is. I believe it is. I just checked, and I think I have all the grades in the book for that. Okay, so we are going over logarithms. Logarithms.
To recycle it or something?
This I think is the new one.
I thought it was the other one. Here, let me show you.
Or maybe not. Oh no, you're right. You're right. Yeah, I'll take it. Thank you so much. Does anybody need another final exam review packet? I ended up with extras. No? Okay. Beatrice, I've got this. I have to recycle it, or maybe make a giant paper mache something out of it. I don't know.
Mr. Munir, how's the exam looking?
It's done.
It's done?
It's 40 questions. Yeah.
Multiple choice and short.
I think it's pretty easy. I think it's, but I shouldn't say that either. But it's hard. It's like hard as hard. You have to study for hours now.
So are we all in the South Bay? We're all just taking these exams together, like
Yeah.
frozen, and then keeping one ratio of multiple choice. Will you be in the classroom?
I'm gonna be there, but I'm not going to be able to answer questions.
No, yeah.
Like I will be there just to help with the administration of it,
Yeah.
so everything goes well. Yeah, but I'm probably just gonna be there in the very beginning, honestly.
Yeah, and then go to the grill, get some coffee. Like, Mr. Munir, you just can't be. Mr. Munir, here's the grill. I can't stop
Just
kidding.
take orders. Okay. So, no, you're good. I just it looked like a very long white flag. Okay, let's get ourselves situated.